The next speaker is Dott Korotkov, and the presentation will be about the Russian project with nuclear DNA.
Ladies and gentlemen, on my own behalf and on behalf of Mr. Potapov, let me once again express my gratitude to Dr. Vladimir Hermes, Professor Speranza, and the staff of the International House for Scientific and Technological Cooperation for organizing this conference. We are convinced that the conference fully enable its participants to express in the form of the friendly dialogue and debate their point of view on the global problem of providing humanity by the necessary energy resources at the Earth warming risk. The next part of my speech I asked to Katerina to help me to translate my Russian speech in English, because my English not so good, because like a children speaking of the 5 years old, not more. Sorry. At first I want to tell about the purposes of our visit and talking with you. Russia so far, why we speak about Russia using more the problem of energy resources in Italy. I think in the future, if our project will be finished in good style, the cost of electricity in Italy may reduce from the 25 cents maybe on the 10 less than it is now. Why it will be the situation? Okay. Because we offer a new type of fuel and synthetic oil. Italy will be used this component in their supply of energy will reduce the cost of electricity also. And heating and fuel for engineering for reduce dangerous pollution in the atmosphere of the Earth. The latest development of science by the industrial matters of the work of documents of the Paris Conference in 2015 to reduce the emission of the greenhouse gases in the Earth atmosphere were an important impetus for improving relevance of this problem and the complex formulation of the task. Many conferences on this topic are being held in other countries of the world of this regard. Addressing to the head of the Catholic Church Pope, to the Christian world, and to all the inhabitants of the earth to prevent the greenhouse catastrophe is noteworthy and gives also hope for the success in this area. We now in the Italy, in the Roma, and the Pope live in this town. The topic of my speech is a prelude to the main part of the report, New Energy, the Russian project, with the nuclear DNA, which will be set for by Mr. Potapov. The fact that the very happy candidates working for more than 40 years ago, a long time I worked in Kazakhstan, Republic, Institute Energy Grid project. We had a design organization to create electricity of the Soviet Union. I took part in many worth of its development, including its long-term period of up to 50 years. Significant place in these studies was the devoted development of the nuclear power of the Soviet Union, coal, thermal, and hydroelectric power complexes of Siberia and Kazakhstan, the creation of having no analogy in the world practice, the transmission electric line of ultra-high voltage, 1150 kilowatts alternative current, and the line of the voltage 1500 kilowatts direct current, linking Siberia with the center of Russia over 4,000 kilometers. During the 70s of the last century, Soviet state construction program for 50 years for establishment of new power plants at the various times with a total capacity of 400 gigawatts taken, including nuclear power plants with the total capacity of about 200 gigawatts in the north part of Russia, nuclear fast breeder in Kazakhstan and Urals, as well as a complex of the thermal power plants with the total capacity of 80 gigawatts in Siberia and Kazakhstan. At that time, there were also outlying plants of the oil and gas industry in USSR, and the active phase of their development began. The meaning of the task for the evaluation of the USSR fuel and energy complex seemed a pipe dream commensurate with the reasonable optimism of Mr. Potapov report on this conference. However, the active pace of construction of the power facilities showed this reality. Construction of the planning nuclear plants, power plants, hydropower plants, thermal power plants, having no line analog in the world of the 1150 kilowatts transmission line from Ekibastuz in Kazakhstan to Urals, was carried out of period 1955-1990. Unfortunately, this plan partly failed due to the collapse of the Soviet Union. The slide one shows continually the projected 1,001 kilowatt transmission line, alternative current and direct current transmission line in the USSR in the time 1976, new, very so much time before. And today the general scheme of development of the Russian electric energy sector for the period up to the 2030 is approved, slide 2. As you can see that the slide 2, according to the approvement master plan of the development of Russian energy, it was assumed that the active extension of the electric network 5,000 kilowatts would be in the proposed in our report areas of the accommodation of the complex of the wind and nuclear power plants near the Yamal Peninsula, a place for the daily production complex, as well as the sewing of the daily power of the Central Asia and China along the Ob River. This fact increases that the investment attractive to the project to build wind farm and nuclear power plants and complex for the production of MEA of Yamal Peninsula, as well as a project of construction of a channel to the transfer water from the northern rivers of Russia to Central Asia and China. This is our opinion, should be considered by foreign and domestic investors who study the problem of the
Ma became a master of nature after involving in his activities the energy resources not related to his biological cycles. This is primarily due to the invention of the steam engine and coal involvement into the economy. Taking into account the average daily rate of the physiological energy consumption by man as 12,000 kilojoules, the entire population of the Earth consumes 3.3 times 10 in 19 joules per year. According to the report of the British Petroleum, in 2014, the total world industrial and domestic energy consumption, excluding food, was 5.23 times 10 in 20 joules. I designate ratio of non-physiological to physiological consumption of energy as an energy human leverage. Today it is about 16. It is through this leverage that a man achieves a dominant position in nature. Under such assumptions, the human mind acts as production, storage, transmission, and conversion control system. Advanced nations have energy leverage over 100 units, and the undeveloped ones have only a few units of it. The animal's leverage is equal to 1. The dominance of some nations and states over others is determined by the grade of energy leverage. For this reason, policy and energy are inextricably linked. However, the energy leverage has a limit, which means that there is a limit of human power. If we take the constant current rate of growth of the world population as 1 person for a long time, after 3,000 years, the mass of humanity will become equal to the mass of the Earth, and in 5,000 years, the mass of the Sun. This is an obvious absurdity. Thus, at some point, the population shall be limited by the energy mass reasons. Recently, moreover, it became clear that the population would be limited and due to the side effects of energy production, namely the greenhouse effect. The recent Paris Climatic Conference was devoted to it. Thus, setting a development plan, the nation must first specify the energy technologies. These technologies shall determine the strength of the nation and the extent of its dominance in the international space. At the time, French President de Gaulle proposed to create a single entity from the Atlantic to the Urals. The Russian leader, Michael Gorbachev, proposed the creation of the United Europe from Lisbon to Vladivostok, but they did not discuss the energy aspects of their proposals. Therefore, their initiatives had failed. Proposed in our report a plan to create new power enables for 800 million people in Europe and 1 billion people in Russia, according to the capacity of the areas, to be supplied by energy on the standard of living of about 40,000 United States dollars per year of gross domestic products per person, to decide away the greenhouse problem for the energy consumption. Today, 520 million people live in Europe and 146 million people in Russia. If politicians and nations agree on these targets, then we may create a single economy from Lisbon to Vladivostok. New energy, presented in our law, is based on the ideas of Nobel laureates George Orwell, United States of America, and Carlo Rubbia, Italy. A whole galaxy of Russian scientists and engineers. It is free from the problem of the exhaustion of stocks of oil, gas and coal, provides the basis for energy independence from the foreign energy suppliers. As indicated above, no energy prices would not be restricted to humans, who would buy out energy full in the long run. But in the current conditions, hydrocarbons are cheap, and the new technology must compete with them. To succeed, it has been tasked to achieve the cost of no more than $50 per barrel of oil equivalent. It is sold in the project on the Yamal Peninsula by the following way. 1. Maximum use of the current resources of unsold methane. The volume of available methane today is about 5 trillion cubic meters, and in the future, 25 trillion cubic meters. Translation of not renewable reserves into renewable ones is tempting for the oil and gas companies. 2. Availability of prepared for use oil and gas infrastructure. 3. The highest wind energy potential of the peninsula. 4. Availability of the sea treatment features for the products and receiving of carbon dioxide from and to the east and west direction. 5. Complex gas chemical technology combining together in one cycle the use of methane, cheap associated petroleum gas, carbon dioxide, electrolytic hydrogen and oxygen. 6. The applying of two parallel electrolyzers, water and carbon dioxide, at high temperatures. The current efficiency of the electrolyzers approaches to 100%. 7. Mass production and the construction of only single type of the wind turbine of specific 10 megawatt. 8. The serious manufacturing of only single type of the molten subcritical nuclear reactors and accelerators to them, and the rest of the main and auxiliary equipment for the nuclear cycle. 9. The concentration of the nuclear cycle in one place, including the reprocessing, isotope and fuel plants, the exclusion of the transportation of nuclear components. 10. The reciprocal improvement of the wind power plants and nuclear power plants parameters through the external heating loop. 11. Opportunities of the harmless discharge of nuclear power plants surplus heat. 12. A single set of materials manufactured for the production of the wind turbine and nuclear power plants, primarily with regard to rare earth elements. 30. The uniform thermodynamic scheme for the wind power plants, nuclear power plants, and gas chemical plants. 14. The presence of 2 wide summer months for the capital repairs of the wind power plant and 10 high-intensity winter months to generate. 15. The widespread use of superconductivity for the inside technological tasks. Power transmission, efficient accelerator. For power transmission and efficient accelerator. 16. The presence of processing hydrogen solves the problem of providing the conditions for a broad application of superconductivity. 17. The large-scale use of unmanned airships of semi-rigid design developed by Italian engineer Forlanini for transportation of the large-scale components. 18. The presence of helium in the Yamal fields to fill the airships. 19. The possibility of the serial step-by-step commissioning of the whole complex of the energy equipments. Reduction of payment of the bank interest charges. 20. The mutual backup and smoothing of electricity consumption in the gas chemical complex on the base of the wind, atom and methane energy capabilities. The complex of these measures is able to provide inexhaustible electricity at 0.7 to 1 cent of United States dollar per kilowatt hour, which give the required cost of 1 barrel of synthetic oil at $15. In the future, it will be lower. The building of a united Europe from Lisbon to Vladivostok will require, in addition to the solution of the energy problems, also the unification of the democratic standards. It will be a question of the optimal state structure, revealing to the limit the person's abilities and guaranteeing his rights and freedoms. Today, the most effective democracy is recognized by a large number of countries and people to the American democracy. This opinion is not certain. However, the model of the Novgorod Russian democracy, the 880th anniversary of which is celebrated this year, gave an example of a much more efficiency and spirituality. Now, this is already the subject of another conference. Thank you for your attention.
Any questions?
Thank you. Very interesting global vision. Now, there are new technological developments. Let me mention some. For example, if you want to make a subcritical nuclear reactor and produce neutrons, our system with the high field is far cheaper than accelerators. The ignitor machine, as is designed to ignite, but if you don't ignite, it makes many neutrons. That is quite inexpensive. This is one point. The other one, there are new superconductors. I think we developed a special one in Italy, but now also in the US. Magnesium diboride is very cheap. It works at temperature between 10 and 30 degrees Kelvin. Very light. It's already being used at CERN for bus price. So I think your idea can be improved by all of these elements.
Таких параметров сверхпроводимости мы были скромнее в своих предположениях, у нас хуже приняты в расчетах суперпроводимости.
Such low degrees, 10, 30 degrees. Our calculation are a bit higher. However, it's a point.
Вы говорите о слишком хороших показателях суперпроводимости. Мы пока об этом не знаем, по крайней мере, не готовы были принимать их в расчет.
We was not ready to accept such amount, such studies, because in Russia at the moment we don't have such data.
То, что касается ответа на второй вопрос, во-первых,
Can you please repeat first question a bit? The first question a bit not clear. Can you please repeat what exactly they did?
Dico in italiano, non c'è bisogno di fare degli acceleratori come propone Rubbia, perché se usa la nostra tecnologia delle macchine ad alto campo, così come sono, è facile fare dei reattori per i reattori sottocritici.
Технология Карла Рубия в России получила очень хорошее развитие, то есть она была еще заложена начиная с конца 50-х годов, поэтому мы отталкивались от уже готового пути. Путь был готов, мы не готовы были рассматривать другие направления, поэтому вот это направление подкритических реакторов с внешним источником нейтронов для нас является основным при построении гигантских атомных АЭС.
Since 50s they was working on this idea. However, it will take into account this idea, but for the moment they was not taking into account this point, and they worked from 50 years for this topic.
Предполагаемая мощность атомной электростанции будет 60 гигаватт, она будет набираться из 60 блоков электрической мощностью по 1 гигаватту каждому. Естественно, это очень большой объект, требующий совершенно новых подходов.
However, I want to say that the total amount will be 60 gigawatt of the plant, and it's not a bad idea, it's quite realistic with that investment.
Any more questions? At the end of the session, I would like to thank all the speakers. Now we have our... Thank you.
Добрый день, господа. Тема моего доклада – новые технологии перевода водного транспорта на топливный режим с применением сжиженного природного газа в качестве дешевого и экологически чистого моторного топлива.
The topic of my speech today is a new technology of transfer of water transport in dual fuel mode with the use of liquefied natural gas as a clean and cheap alternative motor fuel.
Сжиженный природный газ – это природный газ, искусственно сжиженный. Он сжижается при температуре минус 160 градусов Цельсия. Его сжижают для того, чтобы уменьшить объем и для облегчения транспортировки. Основные преимущества сжиженного природного газа по отношению к традиционным нефтяным моторным топливам в стоимости он примерно в 2-3 раза дешевле. В компактном хранении при сжижении объем природного газа уменьшается в 600 раз. Это экологически чистый вид топлива, поскольку при его использовании концентрация вредных веществ сокращается по разным компонентам от 3 до 7 раз. Ресурс двигателей увеличивается примерно в 1,5 раза. Ну и это один из безопасных видов топлива, поскольку прежде чем он перейдет в газовую фазу, да, он должен нагреться. Он поэтому не горючий.
So, as you can see, liquefied natural gas is natural gas artificially liquefied by cooling it to a temperature of about minus 162 grams Celsius in order to facilitate storage and transportation. The main advantages of LNG behind the oil fuels you can see on the slide.
Сжиженный природный газ может применяться в двигателях в разных вариантах. Первый вариант – это газодизельный режим. Для того, чтобы его применить на транспортной установке, в двигателе, необходимо оснастить это транспортное или энергетическое устройство дополнительной емкостью сжиженным газом. И в этом варианте примерно 20% используется дизельного топлива как запальная доза и 70-80% природного газа, жидкого природного газа, как более экологически чистый и более дешевый вид топлива. Второй вариант – когда двигатель полностью переводится на сжиженный природный газ, но этот вариант более материальный с точки зрения затрат, поскольку нужно значительно переделать сам двигатель. Но зато двигатель будет работать на 100% на сжиженном природном газе.
Liquefied natural gas in diesel engines in vehicles may be used in two ways. Option 1. Gas diesel mode. It involves the use of two fuels. 20% diesel fuel is used as low dose and 18% LNG. In this case, gas diesel injector is installed or gas air mixer is used on the engine to install additional LNG cryogenic fuel tanks. Option 2, gas mode only. The engine runs exclusively on LNG. Gas regime is costly since it's necessary to install a new gas engine or to carry out major changes in the diesel. In this case, also set a cryogenic fuel tank.
Использование сжиженного природного газа в двигателях транспортных средств, в частности для грузовых автомобилей, позволяет на 1 километр пути в первом режиме, чисто газовом режиме, сэкономить около 15, 17, 16%, в газодизельном от 5 до 7%. При этом стоимость снижения затрат на эксплуатацию транспортного средства в первом варианте, когда вы используете 100% сжиженного природного газа в качестве топлива, составляет около 13-15 тысяч долларов на единицу техники. Это в год эксплуатации. А снижение стоимости эксплуатации, годовой эксплуатации транспортных средств в газодизельном режиме позволяет экономить примерно от 4 до 6 тысяч долларов США на единицу техники.
Using LNG in trucks engines will reduce the cost of 1 kilometer of road. In gas regime at 50-60%. In gas diesel mode at 5-7%. Reducing the cost of 1 kilometer of road for 50-60% will allow saving annually from 30 to 50,000 US dollars from piece of equipment. And reducing of cost of 1 kilometer to 5-7% will allow annually saving at about from 4 to 6,000 US dollars from a piece of equipment.
В настоящее время
Нет, телефона нету.
В настоящее время сжиженный природный газ применяется в качестве альтернативного топлива во многих странах мира. Это в Соединенных Штатах Америки, в Европе, в Китае. Необходимо отметить, что уже создана инфраструктура получения производства сжиженного природного газа и его использования в качестве моторного топлива. Вот на данной стадии представлена территория карта Соединенных Штатов Америки, где показано, что практически в любом городе вы можете заправить свой автомобиль сжиженным природным газом. Также необходимо сказать, что в мире уже существует достаточно широкая, созданная и сильно производится достаточно широкая линейка автотранспорта на СПГ. Ну и на данном стадии представлены некоторые экземпляры этой техники, которая может работать именно на сжиженном природном газе.
Currently, LNG is widely used as an alternative motor fuel in many developed countries of the world, for example, in European countries, in the USA, China and others. It should be noted that at present already there is a well-developed infrastructure of LNG production and its refueling. For example, you can fill your car with LNG in many cities of the USA. Also, it's necessary to say that in the world there is a wide range of mass-produced vehicles on LNG. The slide shows some examples of utility vehicles on LNG and infrastructure of LNG filling station in the United States and Europe.
Необходимо отметить, что сжиженный природный газ используется не только для автотранспорта, но и для автономного энергоснабжения. Вот на данном стадии показано использование СПГ для энергоснабжения отелей на юге Турции. Практически каждый отель имеет в своем составе емкость для хранения сжиженного природного газа. Сжиженный природный газ завозится из портов в Измире и Стамбуле. И данная технология, она позволяет производить электрическую энергию непосредственно в отелях в час пик, в утренние часы и вечерние часы. Хочу отметить, что вот эта инфраструктура перевода, создания системы автономного энергоснабжения для отдельных объектов, в частности для отелей в Турции, было создано за очень короткий срок. Это примерно 3-4 года. То есть это говорит о том, что сжиженный природный газ и технологии, которые сейчас уже есть и существуют на рынке, позволяют в короткие сроки и очень эффективно перевести этот объект на применение сжиженного природного газа.
It should be known that LNG is widely used for the independent power supply for the individual objects. So, in this slide, we can see photographs of LNG storage system in the territories of some hotels in the south of Turkey. Currently, those systems are equipped with almost all the hotels for stand-alone power supply systems in the clock peak. I will say that all this work to create LNG storage and use infrastructure for independent power supply in these hotels was made in a very short time, at about 3 or 4 years. LNG is delivered from the south to the south of Turkey from the north part, from Istanbul and Izmir area. Next.
В настоящее время наиболее критичной ситуацией по использованию или наиболее перспективное направление по использованию сжиженного природного газа — это направление использования для водных видов транспорта. Эта проблема связана с тем, что в настоящее время более жесткие требования предъявляются к выбросам этих видов транспорта, именно с точки зрения концентрации окислов азота и серы от отработанных газов для электрических судовых установок. В соответствии с требованиями международной Марпол, конвенции Марпол, наиболее жесткие требования по экологии относятся к следующим регионам, как Балтийское море и Средиземное море, а также в ближайшее время такие же требования жесткие по снижению выбросов, концентрация вредных веществ в выбросах судовых энергетических установок будет введена на побережье Америки, Южно-Китайского моря и Японии.
Currently, among all modes of transport, the most critical situation is in the matter of application of LNG for water transport. The need to use gas fuel on ships of different propulsions is determined by plans for the introduction of regulations to control emissions of sulfur and nitrogen oxides and the creation of special area of marine waters where these emissions will be monitored. In accordance with the requirements of Annex number 4 of MARPOL organization, the most stringent requirements are set for emissions control area, which includes the Baltic and North Seas, the coastal water of the United States and Canada, the Caribbean, the Mediterranean Sea, the coast of Japan, and the Straits of Malacca.
Введение норм Марпола уже с 1 июля 2010 года установило, что в выбросах отработанных выхлопных газов на электрическую установку состав серы должен быть менее 1%. С 2015 года районы Балтийского моря, Северных морей, а с 2018 года других морей эти требования ужесточаются, и уже по требованиям Марпола эти выбросы должны составлять менее 0,1%. Надо сказать, что именно применение сжиженного природного газа является наиболее перспективным и наиболее таким экономически оправданным способом решения удовлетворения требований Марпола.
Standards of MARPOL from the 1st of July of 2010 allowed the use of fuel with sulfur content up to 1%. By 2015, in the Baltic and North Seas, and 2018, in the other continents of the world ocean, the level of sulfur content in bunker fuel must not exceed 0.1%. Nitrogen dioxide content should be reduced by 80%. The use of LNG as the main marine fuel has a fundamental advantage that allows to complete eliminating emissions of harmful components into the atmosphere.
Примерно в настоящее время насчитывается около 100 судов, которые уже работают на сжиженном природном газе. Планируется, что уже к 30 году, то есть практически через 15 лет, численность этих судов, которые используют СПГ в качестве топлива, будет примерно в 370 раз больше, чем сейчас. Больше, около 4000 судов будет. Вот некоторые из этих судов здесь представлены на этом слайде. Ну и хочу отметить, что эти требования, они определяются в том числе и требованиям Европейской комиссии. Примерно на 2020 года все морские порты ЕС, а с 2025 года все речные порты ЕС должны быть снабжены терминалами по принятию и по заправке судов сжиженным природным газом.
If today there are about 100 sea and river vessels on LNG, by 2030, according to the forecast, there will be 3,700. Some of the existing vessels on LNG are presented on this slide. In accordance with the strategy prepared by the European Commission, by 2020, all maritime ports of the European Union, and by 2025, as all the major river ports must be equipped with items bunkering liquefied natural gas.
До настоящего времени в Российской Федерации природный газ не использовался как моторное топливо не только для водных транспортов, но и для автотранспорта. Поэтому была поставлена задача перевести впервые, приобрести такой опыт, перевести судно на сжиженный природный газ. В 2014-2015 году под непосредственно моим руководством в соответствии с государственным контрактом были проведены работы по переводу энергетической судовой установки речного судна прогулочного на сжиженный природный газ. Вот на данном слайде представлено это судно. Это было специально купленное судно для того, чтобы был проведен.
Currently, liquefied natural gas is not used for ship power plants in the Russian Federation, in the Russian water transport. The main reason is the lack of the domestic experience in the creation of marine power plants using liquefied natural gas as motor fuel. In 2015, 2040-2050 under the direction of our speaker, in accordance with the state contract, was designed and developed the first Russian project to create a ship power plant with liquefied natural gas. In this work, specially purchased the ship Nuove 6, gross tonnage about 210 registered ton, previously only operated on diesel fuel, has been translated into the use of liquefied natural gas. The ship Nuove 6 is presented on the slide.
Были разработаны следующие новые технологии, которые, в общем-то, раньше нигде не использовались. Это технология перевода судовых энергетических установок дизелей на двухтоплный режим, с использованием дизелей, с использованием СПГ без демонтажа существующих дизелей, с помощью специального навесного оборудования. Была разработана новая технология снабжения топливными емкостями судов без заправки непосредственно емкостей на судне, а уже поставка этих емкостей заправленными на специально подготовленные площадки на судне. Была разработана новая технология горячего промежуточного контура от рубашки охлаждения дизеля для подачи восхорения, для получения, для газификации СПГ. Ну и была разработана новая технология автоматизированного управления двухтопливного режима.
In the course of this project, new technology have been developed. First, translation technology of American diesel engines to dual fuel gas diesel operation using LNG as a main engine fuel. Replacement rate of 17% without dismounting the ship diesel engine with a special attachment. Ship LNG refueling technology through the use of quick fit isolating modules for storing cryogenic fuel on board. Technology of the hot intermediate circuit with heat transfer medium to vaporize the liquefied natural gas from the gas diesel cooling system of ship power plant. Automated control technology of two full mode of operation of ship power plant to control the main parameters of gas diesel engines.
Технология заправки судов жиженным природным газом, вот она представлена на данном слайде. Жиженый природный газ заправляется непосредственно в пункте заправки емкости, доставляется специальными перевозчиками данным образом и уже заправленные устанавливаются непосредственно на палубе судна. Это позволяет избежать различных проблем непосредственно в самом судне, захолаживания, обслуживания и так далее. Все это ложится на плечи квалифицированных специалистов на месте заправки. То есть судовладельцу практически не приходится решать проблемы жиженного природного газа у себя на борту.
When creating a ship on LNG for the first time in the world in Russia, there has been developed and applied technology of using of quick-feed cryogenic modules for LNG on board. The developed technology provides load already refilling with liquefied natural gas cryogenic quick-feed modules. It reduces the cost of potential owners and eliminates all problems associated with technological issue of service model, refueling, cool down, cooling, disgassing, draining, storage, haulage, etc., which are carried out on-site refueling of LNG models by qualified experts.
Доставка вот таких емкостей, она может осуществляться любым видом, в принципе, транспорта. И в любом месте, где есть возможность подойти судну к причалу, есть площадка для погрузки, эта погрузка может быть осуществлена.
In accordance with the developed technology, the foundation for the quick-feed cryogenic modules was prepared in advance on the open upper deck of the ship. It is a frame made of connected metal I-beams welded to the ship to the side of the vessel. This slide shows photographs of the installation of cryogenic tanks on the ship. Delivery of cryogenic modules can be carried out from the place of production filling space to LNG bunkering location, for example, river port, by specialized trucks. Replacing cryogenic modules with LNG can be carried out in any place where possible mooring the vessel and has space for a loader, for example, a truck crane. Replacing cryogenic units will not take more than 3 hours.
Уникальность этого проекта заключается в том, что с этого судна не были демонтированы судовые энергетические установки дизеля, а просто было оснащено машинное отделение с специальным навесным оборудованием, которое, в принципе, позволит перевести энергетическую установку с судовой на двухтопливный режим. Прежде чем, конечно, разработать навесное оборудование, был создан передовой стенд, там были отработаны все нюансы, все вопросы, связанные с эффективностью работы навесного оборудования. Но это позволяет уменьшить затраты на перевод судна на жиженый на газ для владельцев судна.
The nucleus of this project consists in that fact that transfer of ship power plant type Nuove vessel on gas-diesel dual-fuel operating is performed without dismounting the regular marine diesel engine. The vessel is further equipped with a set of attachments, gas equipment with automatical control system of two-fuel mode, optimized at the shore test bench to replace 70% of diesel fuel when operating at rate power. This approach greatly reduces the cost of transfer of the vessel or other vehicles on the gas-diesel cycle operation. A version of the external mixture formation was selected in the translation of the marine diesel engine on dual-fuel mode. This charge mode, when natural gas is supplied into the intake air manifold from which the gas mixture is fed into the cylinders of the diesel motor.
Экспериментальные исследования были проведены вот здесь, на судне, уже непосредственно на шлаках и ходовых испытаниях. Из испытаний проходили в акватории речного Волгограда, города Волгограда. Значит, все режимы были испытаны, все заявленные технические параметры были получены. Проект был принят комиссией государственной, и значит, все результаты были отданы.
Experimental mooring and sea trials of the gas vessel were in the water of Rio Volga, near Volgograd city. They showed that the use of LNG as a fuel for inland waterway vessels is not only technically but also economically feasible. The slide shows a photograph of the vessel during the sea trials.
Спасибо за внимание.
Thanks for your attention.
Thanks. Any question?
Among other things. And one thing I've been and one thing I've been explained a long time ago is that the average cost here in the Mediterranean of all ship owners is 50%, 54% on average on fuel. This was the consortium I'm president of has been working basically on ship routing, and we proved that on routing from the north to the south of the Mediterranean, we can save on average 30% of fuel cost, and among other things, of course, safety and also comfort, which is another very important topic for some. So I think this topic is very important, and I'm willing to organize a specific meeting on that involving ship owners, because I know that actually I have also been involved in the European project of Commissioner Bosch, so-called blue paper on marine navigation and so on. And so I find it very, very important. Actually, I'm an oceanographer, so I'm more expert in sea navigation. But probably starting from river navigation is easier for several obvious reasons. But in my opinion, it's a very, very important topic. Again, and I'm willing to organize together. I can involve, I'm every day in touch with all the major companies here in Italy, which are very last thing to give a practical idea for tourist navigation. Civitavecchia, here near Rome, is a little better than Spain since 15 years or something like that. For example, in that area, Italy is quite sad.
Я благодарю за те хорошие, добрые слова по адресу этого доклада. Мы изучили многие технологии, которые владели зарубежные компании по переводу.
We have studied a lot of technology that other companies used before.
И то, что было показано на слайдах,
the way we work, that you can see.
вот в таком виде и нет ни у кого. Мы первый раз испытали, поняли, что
Nobody work in this way. And when working, we understand that it's a very simple and very clear way to translate.
И акцент делали на то, чтобы минимизировать затраты судовладельцев, чтобы было понятно с одной стороны, а с другой стороны выгодно этим заниматься.
And we try to all the time thinking about the owners, that the cost of translating of diesel plant will be the most cheaper possible for the owners.
Сейчас мы разрабатываем новую технологию производства получения сжиженного природного газа.
Now we are working about
Максимально приближенного к поставщику, чтобы была очень дешевая господа.
in the team of produce the cheaper way of producing LNG gas.
Если у вас есть интерес, мы готовы совместно это все сделать.
If there is any interest in this topic, we are ready to cooperate.
Okay, thank you for the discussion. Now we have to pass to the last speaker, Professor Naviglio from University of Rome.
Thank you. It is a difficult job to be the last one, and with a big delay, so everybody is tired. So I will try to, first of all, I will speak in English, basically better for our guests. And I think that it is better if we try to make a very concise presentation and eventually space to questions. So for this reason, and since there is no device, I understand that for the one changing of the slides, I will move here so that I can make probably a faster presentation. So, I will speak of something that as an issue is a little different from what has been analyzed today. Today, you've seen a lot of scenarios, a lot of technologies and policies. I am going to speak of something that regards the development of a technology that we call poly to oil. It is a new technology for a complete plastic waste valorization, and we will see the aim is to eliminate completely the plastic waste and to produce high value liquid I anticipate that we build a prototype plant in the south of Italy, in near Reggio Calabria, and this technology has shown to allow to a complete reuse in the form of liquid fuel of the residual plastic waste that otherwise would be destined to landfill. In the world, every year, we have a production of 300 million tons of plastic material. And in the European Union, we have a production of 57, you see the upper part of the slide, 57 million tons of plastic. Most of this plastic material that is introduced into the market becomes a waste. We see that in the European Union, we have about 20% of the introduction of plastic material into the market. And this is what occurs at the end. What is the final story of this plastic material? This refers to the European Union. And we have about 26% of recycling, about 38% of landfill, and about 36% that is energy recovery. And here we have a splitting among the various countries. In the upper part, we see countries in north of Europe, and we see that their law states that no residual plastic waste basically is allowed. So we have a recycling that is about 30%, and most of the plastic goes to what is called energy recovery, but it is a very low value of energy recovery because it goes to incinerators, where we have an energy utilization of the waste that is 8-10% of the real energy value of the waste. And this is a photograph of the initial prototype plant that made the production where we made the initial test, and it produced, showed the reliability of the process for about 3 years. This technology is implemented in a fully automatic industrial plant, and it is a started operational at the treatment and selection platform of various types of clay waste. I will spend a few words about this. And it is compliant with the Italian and international regulations, and it is operating in the facilities authorized for this operation. The company that has been working on the development of the technology is a spin-off of the University of Rome that was established some 40 years ago, and it includes several small medium enterprises. And the main premises are in Rome, Turin, Maranello, Naples, and is a premise also in the United States. So the problem is, and our target was to treat not good value plastic waste. You can imagine a factory where you produce plastic product. There is some part of the material that remains as a waste. But that is the good waste. Our aim was to tackle the worst imaginable plastic waste, because if we were successful in this, we would be successful for any type of plastic waste. The criteria is in principle easy. We have a humanity-based organic waste, and we have first a part of the plant where there is basically a selection of all the dirty material and the polluting material that is included in the final plastic, the dirty plastic waste. Then we have drying, plant, and finally we have the production of the liquid fuel. The criterion was to use, as I said, as input material a very bad waste. And the big problem of this type of waste that is the final activity of the platforms that in Italy are created for recycling, the recycle of the plastic material to the highest level. What remains from this recycling activity is something that has really no value, and it is a cost to the community. There is a consortium, Korotkov, in Italy, that pays people in order to take this material. And the final decision of the material is landfill, or it is burned with very low efficiency, or it is even burned in the atmosphere. These are the sections of the plant, and eventually these things may look at this in the presentation. These are the ranges of the composition of the material that are accepted as input, or for which we designed them, especially the first part of the plant. And we include polyethylene terephthalate, polypropylene, polyethylene, PVC, polystyrene, and so on. But we see that in the composition range there are also favorable carbons, metals, because the very dirty plastic material has a lot of inert and even sometimes harmful substances. So it is extremely critical, a good treatment, in order to save the environment, because we want not only to have an energy use, a positive energy use, but mostly we want to save the environment. These are also a comment about the suitability of the various polymers and materials that are present in final waste. And it is typical plastic waste material that for us is input material. So we are able to treat this type of raw material. And in that company in the south of Italy, they have this aim. They try to obtain from the residual waste that comes from various towns, and even if there are some platforms with recycling, and at the end of the study they send to this center their product. In this center they try to take what is still good, that material, and what remains is plastics, what we use as input material. In Italy there is a production, Korotkov has a production per year of 800,000 tons. And this is mostly landfill, or it is burned as RDF. With this technology, we really have the use of more than 90% of the plastic fraction collection. This is, we go very fast on this. This is presently how, which is the composition of a typical town in Italy with about 40,000 people that produces yearly about 20,000 tons of waste. And this is the composition including the organic matter and the plastic, the glass, and so on. At this moment, with the present technologies, we have about 55% of the urban waste that finally goes into the environment. Okay? It's not the recovery in any case. Using our technology and adding this technology to another technology we are working on, is we reach the target starting from the same amount of urban waste. We arrive at the target of having only 50% of final material that goes to the market, and it is basically inert material. In this, the process that we started, we have the transformation of the polymeric fraction of the input material, and the lighter fraction is used for producing thermal energy and electric energy for the plant. Okay? And the heavier fraction is recirculated, and we have the production that is of the liquid fuel. The production of liquid fuel is 736 grams that may be partially used and but mainly is sold for each kilogram of polymeric material. This is a photo of the prototype plant during its production. And this is a mass balance for an industrial plant. The industrial plant has a capacity, in our reference, of treating almost 10,000 tons per year, but obviously we make modular plants in order to tackle higher productions. And we can see that from this almost 10,000 tons per year of input material, we have about half of that value that is the liquid high value liquid fuel. And the electric energy efficiency defined as kilowatt of associated with the liquid fuel produced per kilowatt of plastic waste is over 74%. That is something that is incredible with respect to the normal use that in most advanced countries is applied for the management of plastic wastes. This is, we are building at this moment the first industrial plant with a capacity of 8,000 tons per year. It is a three-dimensional scheme. This technology was considered internationally as the most advanced solution for the management of plastic waste. And these are the last minute a few figures on some cash flow with two alternatives, we have two possibilities. The fuel produced may be sold as fuel with a range of price that is very variable, depends on who is the buyer. Obviously, if I go to the free market, presently the fuel will be sold at about 500 euros per ton. But if it is the buyer is a company working in oil and gas, we may have a price that rises or a value that rises 1,000 euros per ton. And we see that taking into account the revenues and costs, we have an EBITDA for this type of plant in the range of about 1.8 billion euros per year. So we have with this application about 4 years of payback period. And this is another alternative that especially applicable to the Italian market. If the oil produced is used for self-consumption, self-production and consumption of electricity, we have a payback period that is higher. So, as conclusions, we can say that we now have the availability of a process that is absolutely reliable, is continuous, with practically a reduced environmental impact going to zero as a target, very low cost for the ownership, very high efficiency of the plant of the process, extremely top design. Our plant, industrial plant, is a footprint that occupies about 600 square meters. We may have modular construction plus installation. And we have also an easy adaptation of this process to other types of wastes for the criterion of the design of the and proceedings the process itself. Thank you for your attention.
Thank you, Professor Naviglio, for your presentation. I apologize, but I have to leave because I have to be back in Torino for a lecture tomorrow morning, and I cannot attend to the last question and discussion. But I
can ask. So the question was if the plant is able to work with the tires. The answer is we focus on the treatment and made setup of the plant for residual plastic waste, as you have seen. We also tested for a short time with a small amount of tires. It had a very good performance in the production of the oil, but obviously it did create within the reactors the black bubbles. And in order to apply this technology to the treatment of tires, obviously it is necessary to make the design, make some experimentation and design of the section for the recovery of the treatment, of the valorization of the black powder. So we solved the problem of the continuous feeding of the material through the special design of some machinery that prepares the raw material with very precise size and characteristics. So this should be done also in the case of tires. Yeah, and also in our plant, the depolymerization reactor obviously works without air. So we have special devices that take the material that are in air, and we allow the elimination of the air, and we introduce the material into the reactor without air. And in the depolymerization reactor, obviously we don't want air, otherwise it will be exploded. In our case, the sequence of the machinery allows to have small pieces for the raw material, and through these special devices, we have the complete inertization of the material, we have a final part where we have introduction of nitrogen, and the material is pushed into reactor without any gas, and eventually there could be some nitrogen, but there is no air entry because of also the compliance with the safety rules, and we could not be authorized to build and operate the plants.
First question, first of all, I apologize because they will be very naive questions, but out of curiosity. First question is, can I use that fuel in my diesel engine, any normal lorry or automobile diesel engine?
So we produce this, you saw the product, and we asked the Agenzia delle Entrate, the Italian...
Apart from the law,
technically yes, and because the characteristics of the fuel produced are extremely similar to that of diesel oil. You know that in order to sell at a gasoline station diesel oil, you have to fit with the basic standard. Yes. Now, there are two parameters that are a little aside. The owner of the plant in Palmi uses this oil to feed stationary diesel machinery for production of electricity. We have in this moment a relation with the international oil and gas company that is wishing to create a plant of this type, and they will plant because the characteristics of the fuel is very clear, and with the blending with the mineral diesel oil, they will
Second question, why should I do this when I can take the same plastic and put it into the last generation energy inceneritore?
For the reason of the efficiency. In an incinerator, we bring everything in the incinerator. Yes. The idea of this incinerator is any waste, even bottles of gas, iron, and other things are put inside the boiler, let's say the boiler, and we have a very big volume, and we use basically the energy content, plastic material, and some paper, cardboard, to burn the rest, to heat the rest, and there is the production of fines, and so you need very large combustion chamber, and in the best of the situation, well, first, we have a very high cost for the installation, and in the best condition, you have a very low efficiency in the energy used. And this, in fact, with the generators, generally you have some district heating, that is to use the heat value at low temperature, or even you may have some advanced plants, some steam production, but with an efficiency, global efficiency that is about 80%, 9%. With this plant, we transform the full energy company. Well, first, we have a selection of iron, and we recycle the iron. We select the glass and we recycle the glass. What is not recyclable goes into this plant. And it is plastic waste. We use as liquid fuel oil or liquid diesel oil 70% of the energy, initial energy, because there is a part of the energy that is used for self-consumption in our plant. So it is 70%, it is liquid fuel. And we can use this liquid fuel with a temperature that multiply 40% by 74 or 70%, we have about 30% of energy efficiency, not 8. So this is the reference.
I forgot what is the limit for an R2 incinerator category, because you know that incinerators are divided into incinerators or energy production.
I'm speaking of energy production incinerators.
R2.
And in that case, the efficiency of the conversion is very low.
No, I understand the point. But
And so, and only speaking of efficiency. In addition, we have a huge cost for the incinerators. Germany has 100 incinerators.
of the plant.
No,
Of the plant.
all the plant. And all the waste go there. And if there is also a problem of transportation, there is the roads or the railways are occupied by the trucks that bring the waste into the big incinerator. To my opinion, it's not logical. To my opinion, what is good is to use recycled material and to use the dirty plastic waste that cannot be used anymore. In this way, it's very high efficiency, conversion efficiency. And I have a liquid fuel that I can use where I want. For example, in peak hours,